Hello everyone. Hi. Are you able to hear me?
Yes, sir. Good afternoon, sir.
Yeah, good afternoon. Good afternoon everyone. So okay. So how is the preparation going on for the next week, 10th of July, right? You have the exam.
Yes, yes.
So have you attempted that mock paper?
Not yet, sir. I saw the announcement. No, I didn't attend.
Oh, okay. So did anyone attempt it? No. Okay. So you can attempt that and you can expect almost not almost but a similar type of pattern from each week. Like I'll just open once and just tell you so yeah, so you can expect almost a similar type of questions. Okay, maybe like here most of the questions are like
So, are you
MCQ.
sharing your screen?
Oh, okay, again I'm doing a blender. Okay, now you can see, right?
Yes, sir. Yes.
Okay, so what you can expect a similar pattern of questions. Like there are 13 questions, we'll be expecting 13 or 14 questions in the exam also. Three or four questions from like, so we have just chosen the same number of questions from each week what we have given in the final exam. Maybe one or two less or more, but almost similar. Like from the third, like the sixth, seventh week, you can prepare this type of question. Like you can try to solve if you are getting a number in three-dimensional also. You can just try like from the graded or practice. So you'll get a similar type of questions from this week. And yeah, so these are all the concepts that we have covered in the mock also. So more or less a similar pattern. So mostly the question difficult part you will face is from I guess SBD part. Okay, so you can just
Yes.
go through the properties once again of whatever as we have discussed in the fifth week and the SVD part. See SVD and all. See what you can try to solve in the SVD. What you can do. So if you have been given options, so just go to the options. Like you can't do that SVD whole. Like it will take around like 15 minutes. So that's why most of the question from the SVD will be given in MCQ or MSQ. Okay. So you can just go through the options. From the option you can solve, right? But if you have to solve all the things, then it will take time, right?
Yes.
So it's better to go to the option and don't directly start solving that. So this is the one thing. So you can try out in the examination, or what are the questions there you can try out from the options itself. Okay, because if somebody has given you to calculate the SPD of any matrix, so what you can do, you can just start trying A transpose A, just calculate the eigenvalues, and if let's see that the the middle what the diagonal matrix is whether
The sigma.
satisfied, yeah, that root of that sigma or not. So those things you can check, right?
Yes, yes.
Yeah. So this is the one thing that you can do in the paper also. You can just go directly right, and some other aspect like see if somebody has given you a matrix, okay,
Yes.
only a single matrix with a data set like 1, 2, 3. So how will you calculate? What would be the if I ask how many eigen value would be there for A transpose A?
A transpose A
Yeah,
will be 100.
yeah, and others will be 0, right? So if you have been asked to calculate the eigenvalue, so you can directly calculate. Like, how can you directly calculate? Don't do this. Like, so try to do this one cross three, and then 3 cross 1, so that you'll get a only one element, and that would be the eigenvalue, right? So better to avoid like even 2 cross, like even if you're getting something like 4, 5, 6. So if you have been asked to calculate A transpose A and calculate the eigenvalues, so what you can do? You can just try to solve 2 cross 3, right? So that you'll get 2 cross 2 in the end. Did you get the point? Right. Right.
Yes.
So this sort of thing you can try out in the exam, because if somebody got stuck and, like, for example, this is only matters that is given, and if you are trying out this 3 cross 3 and then you are trying 1 cross 3, so you will get 3 cross 3, and then after you'll calculate the eigenvalue, you'll get the same thing. You'll get the lambda equals to like 1,0,0 only. This is not for this matrix. I'm randomly just telling you. So you'll get the same thing. But it's better to just directly calculate the multiplication such that you'll get 1 cross 1 then, or 2 cross 2. Like, for example, if you're given 5 cross what, some 10 or 1 cross 10 also. So it's better why to go for 10 cross 10. Just do it 1 cross 1, and that will be the eigenvalues of that. So
Yeah, either way, the middle thing should be the common for both of it, right?
yeah. So this thing you can try out. And that, okay, in the revision session, I'll again discuss some of the same. So please attend that revision session so that I'll discuss some of the important concepts that from the paper itself, so that I can will be all prepared for that exam. Okay. So revision session will be on the Wednesday. So everybody please join that session. Maybe that will help you. And if you are already prepared, so okay, it's fine. But you can join that session. So today's session will just solve some problems. It's not regarding the quiz, but this week was already scheduled. So 10th week we'll do everything after the quiz. So we'll just take the 10th and 11th week whole in a 1 week. 11th week is already heavy. 10th week is not that heavy, but yeah. So 10th and 11th week we'll do after the, because we have not scheduled any session regarding 10th week. So because of that, we'll get time for that quiz and all. Okay, so 9th week will complete. 9th week, I guess tomorrow is the final date for the graded assignment also, right? Or it has been
Yes.
extended. It's 9th only, right?
I think it is tomorrow only.
Okay, so these are the questions you can try out. This is the first question. Just try and write in the chat box itself, because I don't think so many of the people have joined the session. So you can write in the chat box itself. A pretty simple one from the 8th, what is this, 9th week, right? From the 9th week. So they are not that difficult. Maybe the last 3-4 questions are a bit complicated, but these are all simple questions. So I'll just go. I'll just give you 2 minutes to solve this. Just try to write in the chat box itself. So 19 people are there, 20, 18, I guess. So please write the answer in the chat box itself. And everyone, please tell everyone to join the revision session, because last time also I told, but many of the people didn't join. I just discussed the same concept, not last term, I'm telling you. And many of the people, I don't know why they didn't scored well, because I almost discussed the same type of concept in the revision session, so that it will help you in the exam. So whatever I'm telling you now also, whatever I told you, 2-3 basic concept that you can use in the exam itself. Okay, so please be like, try, like, otherwise you'll be able to solve, but it'll complicate your calculation in the exam. It's better to do some smartly.
Yes.
Well, 13-14 question will be there. You'll be given, I guess, 1 hour, and if you're using this basic concept, you'll be able to solve in 40-45 minutes. Otherwise, it will take like more than 1.5 hours. I guess so. 2 people, so B is not the correct, I guess.
Yes, so it should be in hours. Yeah, we should convert to minutes.
Yeah. So only 4 people. Okay. So I'll just wait for some more time. So whoever has told B, you can just take it once more. Pras and yeah. So Amir has already told. Okay. So B won't be correct because you have to change that in hour into minute. Okay. So that's why B is the incorrect option. So do I need to discuss this or should I skip this?
This is pretty easy.
You can skip.
It is
So there's nothing, yeah. So the maximum of 3 hours means 180 minutes. And this is for 10x plus 12y plus 5z. And the summation should be less than 3 hours. Okay, so
yeah.
this is the correct option, C option. So the next one is, so these are the 4 points that form convex hull. Now you have to tell which of the following will be under that convex hull. This is also a pretty simple one. You already know the basic properties of the hull, convex hull, how that forms in a. Okay. So D is the correct one. Okay. So 5 people has told B as a correct option. So already you know how does that convex hull is formed, right? So like for example, if you're having a set S and it consists of some random set x1 to xn and that belongs to some R of D dimension, then we'll say that Z also belongs to RD, like Z belongs to RD to be a convex combination of that point in S such that all the lambda such that there's a condition that the summation of all the lambda should be greater, not the summation, all the lambda value should be greater than 0 equals to 0 and the summation of all the lambda should be equal to 1. Or this can, okay, so this is without using this property also we can directly say. So this will just form a what you can trapezium sort of thing.
Yes,
Trapezium, not even trapezium, it's a square. Yeah, so basic is square, and all the points inside this 0 2, this is 2 comma 2, and this is 2 comma 0 and 0 comma 2. So all the points inside this is a complex convex hull, and all the set or the point inside this will be a combination of convex sets. Okay. So under this, I guess this is not there. This is also not there. So only D is inside this. So D will be a part of convex hull, or D is a part of convex hull itself. The next one is, okay. So this one, so whatever the property I told you in the earlier question, so the same property can be utilized here to know which of the following points must be the part of convex hull formed by some points x1, x2, x3, x4. These are basic properties of the convex hull. Why is A not correct? Can somebody tell me?
it adds to more than one. The lambdas add to more than one.
And the B, what's the problem with B?
They're negative, right? It's less than 0.
Okay. So does anybody has any issue in this question also, or it's fine, right?
Yes.
So if anybody is having an issue, you can just ask me in between itself. Okay. So 20 people are there with us. Okay. So do I need to discuss this? The same property that you can use that the J, if you're having some S set and that consists of all the points that belongs to RD, Z, for example, like we'll say Z also belongs to RD to the convex combination of points in S, this S, if whatever the lambda you are taking, so all the lambda should be greater than equals to 0, and the summation of all the lambda I should be equals to 1, right? Then the combination of whatever you get from lambda 1 x1, so whatever the set we were having in the S, and that X was a convex set. The combination whatever we'll get will also be a convex set, or it will be a part of convex hulk. So the next one is, yeah. So this is a storage set to be built in the shape of a box. So this is just a multiplication, or you can say x cross x with a square base. It is to be volume. The volume should be 800 cube meter. The concrete for the base costs 50 per square meter, and the material for the roof costs 70 per square meter, and the material for the side costs 60 per square meter. What is the constant equation first? First, tell me the constant equation, and then tell me the objective of this question. So tell me the both. From this option, you can mark the constant, the objective.
The hx square should be equal to 800.
Yeah. Why?
The volume, right? It is to have a volume, so that is
Yeah, correct. So the volume you can directly calculate, right? So if you're having some, this is the shape of that room. So this is the base, right? This is the base with x. The base is x, right? The same. Okay. So the same thing will be here also, and you can assume the height to be h. So the volume will be what? X square is the area multiplied with the volume, and that should be equals to 800, the unit meter cube. So the meter cube. Any issue in this? Anyone? Did you get the point? How to write the constant? How will you write the objective of this problem? So what is
minimize the total cost.
okay?
So we can multiply the.
So these are the options. Okay. So I don't think we'll be able to see. So I'll just zoom in. You're able to see, right? So you can just mark. Which of the following is the correct one in the fifth one? Out of you need to read the fourth question and tell me the objective of this problem.
It's B, right? Minimize.
D, right? D or
B. Second one.
D for what? Delhi or C for Chennai?
No, like
Chennai or
D,
Delhi?
the second one, D.
Okay, Bombay.
Yeah.
Okay. But you have not given Y anywhere. Y is not written anywhere, right?
Why
X is the base and H is the height. So Y is not given anywhere.
Oh yeah. So yeah, D, the last one. Yeah.
D,
No.
Delhi,
No. C. Sorry.
Chennai.
Yeah, the 240. It's
Bombay.
X plus 120.
So somebody has told C. Okay.
Yeah, C.
So except you, can somebody explain me how C is the correct one? Okay, how C is correct?
See, like first, the area of the base and the roof will be the same, right? So
Yeah,
we can add the total cost, that 50 plus
yeah. So
70
you can add
into
this
x square.
70 x square plus 50 x square,
Yeah.
right?
Then, yeah,
And then
then
you
the
can
the area of one side will be like hx, so 4
16
hx.
4, and then you can multiply x into h. This is what you've done, right?
Yeah, yeah.
Any other one, like it's too like we are feeling like just we are talking and nobody else is replying anything. Somebody is like writing like the answer, uh, like Kamal Kishore and Bipin is replying, Pras and all, but is not speaking up. Okay, so next one is what? So which of the following is a convex function? And tell me also, every time you'll get some matrix or some equation, how will you find that? So did anyone, like everyone knows how to calculate the Bayesian matrix? But because you'll get the problem. Okay, this not this quiz, but next quiz for sure you'll get some problem for the convex function. I know. So first tell me the answer for this. I'll just in 1-2 minutes, and then also tell me how to calculate the Bayesian matrix. If you have been given some difficult problem, how you calculate the Bayesian matrix.
Yeah, A is
Okay.
A is
Yeah. A is correct.
because
One,
we can take the Hermitian and
yeah. So Bayesian matrix, how generally calculate? So like for example, this is a function in the form of f of xy, right? So you can just write xy here and xy here. So here you differentiate with respect to whatever the function you are having, x square, right? Here you differentiate the function with the dx and dy. Similarly, partial differentiation I'm talking about. Similarly, you can do it here, d2 of fx, dx, dy. Similarly, here d2 of fx, fxy, like here everywhere the function I'm talking about, and here d2 y square, right? So what would be the matrix we'll get? What is the matrix
will
we'll get?
be 2
Yeah. So if you'll do
2005.
200, or
Like
if you will differentiate it with respect to x, what you will get?
no
4x.
4, sorry, 4, not 2. 4
And if
0
you'll
0 10.
differentiate again, so you'll get 4, right?
So,
So you'll
yeah.
get 4 here. So here and here you'll get 0. So you can directly write also if whatever you are getting. Okay, one more problem. Okay, I'll discuss it, but I don't know where is that I've written. But okay, so I'll discuss that in the revision session. I forgot where I wrote that. Okay, so here you'll get 5,
10
not
10.
5, 10 you'll get. Okay, so you can directly calculate. So you are getting, so this is also positive, and the determinant of this matrix is also positive. So with the determinant test, you can say this is a positive definite, right? Or you can calculate the eigenvalue also, all the eigenvalues, and then or all the eigenvalues you already
And
seen.
value will be the same.
Yeah, so eigenvalues already you know. So it's more positive, so it's a positive definite, and you can directly say it's a convex function, right? So what about this one? You'll get the both the eigenvalue as negative, right?
Yeah, second one. Yeah, yeah.
And hey, for this case, we'll get one
One
positive, one
one
negative,
negative.
right? One
Yes.
thing, I'll just take out my charger of the laptop.
Yes.
Okay. So yeah. So every time you will get the convex matrix, you can just calculate the Hessian matrix for that, and then you can directly say regarding. So the Hessian matrix will not replicate the exact matrix, but it will be in some like multiple form. So the character, whatever the matrix, the exact matrix will follow, the same character, the Hessian matrix will also follow. Okay. So for this equation, the minimum value of the function, so this z won't be there, like, so, or you can say 0 into z square, subject to a constant. So you have to solve a optimization problem with equality. The constant, so constant whatever you're having is in the form of equal. Okay, so how will you solve this? First solve and tell me the answer. So first tell me which procedure you'll go through.
What is your last one? X square plus y square plus?
Y x square. Okay, g 0 z square. Like zero, like there's
Oh,
nothing.
0 z square. Okay.
Yeah.
Yeah.
So this is the optimization problem where you have to minimize this, and the constant equation is in equality form. So which procedure, which method you'll use to solve this?
You can use the just on the gradient of f equals lambda minus lambda gradient.
So what is the name of that Lagrangian
Lagrange multiplier.
Yeah. So you can use that one to solve this. Tell me the answer, how much you'll get. So I'll just mute for 2-3 minutes. You can tell me, you can solve it. It will not take more than, I guess, 2 minutes.
Sir, I have a question on this.
Yeah.
So when we do the Lagrangian multipliers, so we get the maximum value or the minimum value? We get the maximum value.
Okay, so you can get, so what generally we solve using the Lagrange, you get the point, all the points where the slope of the function is 0. Okay, so at that time you need to check whether the value is minima or maxima. So whatever the values you will get, so like for example, whatever the value x1 next to you are getting, x1, x and xy. So like for example, you got 2 values. So you need to check the function value at that point, whether it's a minima or a maxima. So like for example, is a function. So this is a function. So you get this also, this also. So the slope is 0 at that time, right?
Right, yeah.
Okay, so you need to check the value at which point the value is maxima and which point the value is minima. So the same question they can ask, what is the maximum value? Okay, so at that time you need to check, after putting the value of x and y in the function, you can just check whether this function is giving me the minima or maxima.
Is it point?
So your answer should come under should be less than, I guess, 0.4.
Less than 0.4.
No. Maybe no, it's not correct. That I need to solve this.
What
Sorry.
0.5?
It should not be less than 0.4. You need to solve this.
It
So if
should
you
be
solve,
0.5.
okay, you're getting 0.5. So you can just solve this 2x and then 2y, right? Equals to lambda times what you're getting? 1, 1.
Yeah.
Okay. So what you're getting from here? 2x is equal to lambda and 2y equals to lambda, right? So x equals to
X equals Y.
lambda by 2 and y also equals to lambda by 2. So you can just put it any of the equation, what you will get. So lambda is square by 4 plus lambda is square by 4. Sorry, you need to put it here.
So we can directly equate X and Y.
What?
We can directly equate X and Y, right? If both is lambda by 2.
We can direct equate it with which?
X and Y, because X is equal to lambda by 2 and Y is equal to lambda by 2.
Yeah, but we got the two equations, right? X equals to lambda by 2 and then y equals to lambda by 2. From here, how will you solve that?
So I was thinking like, no, by if A equals B and B equals C, A equals C, we say that X equals Y.
X equals to y.
And then like,
But
we
x
can
equals to
directly,
y, okay, but x equals to y, you'll get so many like values you can get, right? Like if
okay.
x is equals to y, so you can take any values, right?
Yeah, but like, yeah, I mean for substituting in the constraint.
So what you can do, you can just put it here. So what you'll get? Lambda equals to 1, you'll get.
Lambda equals to equals 4.
It won't satisfy the constraint.
Yeah, so this is what you
Yeah,
so
lambda
we'll
equals
put.
1. Yeah.
So you can just put it here and you'll get the value of lambda, right? Lambda by 2 plus lambda by 2 equals to 1.
Yeah, yeah.
And then you'll get x and y.
Yeah.
Correct? And then you need to put it here. So what is the value of x you are getting? 1 upon 2 and 1 upon 2. Right?
Yes, sir.
Or do I make some mistake or what?
Yes,
So it should be minus lambda by 2. X is equal to.
Yeah, here it should be minus. But okay, this is
Yeah,
fine.
but over here, in either case, it will be the
Yeah,
same because of the square thing.
yeah, that is fine because of the square. So we'll get the equation like this. 2x1 or whatever, 2x, okay, plus lambda will be equal to 0. So that is fine. So lambda will automatically adjust itself.
Lambda will be
Yeah.
minus 1.
Okay, even the lambda will be minus 1. That is fine. So the x you'll get minus 1 upon 2, right? So if you'll put it here, you'll get the same value, right?
X will be half and Y will be half.
So 1 plus 2 ka whole square plus 1 plus 2 ka whole square.
And that will be 0.5.
So whether you're putting minus or not minus, it will be same, right?
Yeah.
Yeah. Okay, so I guess 1 upon 2 ka whole square plus 1 upon 2 ka whole square. So 1 upon 4 plus 1 upon 4. So you'll get 0.5, I guess the answer. So 0.5 everyone is getting, right?
Yeah. Yes, sir.
Okay. So yeah, please
Sir.
solve this one. Yeah.
Sir, I have a question on the last one.
Mm-hmm.
So, sir, how do we know this is the minimum value? Why is it not the maximum?
Because we got only one, what you can say. We got only this one, right? Only one slop. Yeah, this is a good question. So how come this is a minimum only?
Because it is convex.
Yeah, and this function is a bit simple, right?
Yeah.
It's a convex function because if you'll calculate the Hessian matrix, you'll get 1, 1 or 2, 2. So it's a convex,
So,
and if you are having a convex, we'll be
only
having
minimum.
minima. You'll get, right. Is it fine?
Yes.
Yeah. So the next one is yeah. This is the next one. So you're having what is the boundary value of y so that the function this is a remain convex. If you're having this some function fxy equals to whole square plus y minus plus 1 ka whole square, that should remain convex. This, yeah, so this will be for any value, right?
Yeah.
Because if you are writing the Hessian matrix also, so can somebody tell me what is the Hessian matrix value? 2 x minus 3.
Yeah.
And
So
if you'll get 2, right? Similarly, you'll get 2 y plus 1, and you will differentiate again, you'll get 2. It's not depending on x and y, right?
Yeah.
Is it clear to everyone how it's not depending on x and y? This function you were having, some function in the form of fxy, right? And you need to see whether this is a function convex. So if you would have got 2y, then you can apply some sort of inequality or equality to get whether this function, like you can just, if you are having 2 cross 2, then you can see whether a is positive, and then what was the equation? AC minus b should be greater than or equals to 0, right? This was the equation, right? To see whether this function is PSD or not. This 1 cross 1, the leading determinant should be positive every time.
Yeah.
Okay. Or if you are having only the diagonal element and you are getting y here, then you can directly say y should be greater than or equals to 0, because it can be 0 for like PSD, like semi-definite cases. Okay, this is fine, right? Should I move to the next one? Any issue in this? No, right? Yeah. Now tell me which of the following Hessian matrix is a convex function. It's a 2 cross 2 only. So I told you so many methods. So you can go through this also. Just leading getting what I told you, leading determinant matrices, or the eigenvalue method.
B and
B and D.
D.
So which one? Bombay and Chennai.
Yeah, Bombay and Delhi.
Okay. Anyone else? Yeah, Bombay and Delhi is correct. Chennai is not correct because
Minus.
you are getting the first leading determinant as negative, right?
So like salary.
Or you can calculate them. So here you can directly say, okay. Here also, if you calculate, minus 5 is negative.
Sir, I have a question here.
Yeah.
Even if let's say one of the eigenvalues was 0, even that it would be a complex function, right?
Yeah. So from here, either the matrix is PSD or the PD, right? So even some eigenvalues are 0 also, that will be a convex function.
And
It
even if
shouldn't-
eigenvalues are 0, still it could be a complex function, right?
Yeah. So it should not be like, it should be a non-negative. Like it should not be any negative. It can take 0. It can take all the positive things. So it should not be a negative one. The eigenvalue. That's the one approach. Second, there are other approaches, but the simple and the most, like what you can say, every time it will be like all the methods will give you the correct one, but many a times you'll get jumbled in other forms. So it's better to calculate the eigenvalue. If you're having 2 cross 2, you can directly say, but if this 3 cross 3, then you'll get stuck. So it's better to calculate the eigenvalue and then directly say. Okay. Anything else? So B, Bombay, and Delhi is correct. Yeah, so calculate this one. The distance of the point on the sphere x square plus y square plus z square closest to the point 444. This is a sphere, like for example, okay, and this is a sphere like a ball whose radius is √3. There is some point here 444, like for example here. Calculate the minimum distance. So this from x, y, z point. This 444. Calculate the distance square. The equation. This is the optimization problem for you, right? So optimization problem is this one, right? The optimization problem you can calculate. So what is the constant equation? Whether the equation for this, what is the constant? Whether it's a equal, like whether you'll get a equality form of equation or inequality form of equation. The constant one.
The constraint is equal to
Yeah. So the constant. What is the constant equation? Which is the constant equation?
the sphere thing.
Yeah, because all the points will lie on the sphere itself, right?
Yeah.
Because you have to calculate the distance, minimum distance from the sphere to that point. Okay. So tell me, okay, so you'll calculate, so you'll get some 2 or 3 values. So tell me the maximum distance and the minimum distance. Maximum distance. So maximum you can directly say, whether if you're getting maximum, you'll just add the what? Root radius, 2 into radius. Diameter you'll add and you'll get the maximum distance, right?
Yeah.
Because the same point, the opposite will be the maximum. So tell me the minimum and maximum you'll calculate directly. I'll give you the option. Do you want the options also? So this option. So your value should be less than 9. And also tell me the point. Tell me the x, y, z where you are getting the minima.
Sir, can you please do this question after this?
Should I repeat that?
Sir, can you please do this question? I mean, solve this question after
So,
this?
Okay, I'll solve this. I'm just waiting for someone's answer and then I'll solve.
Okay.
so is it So square root of 27.
Square root of
27. Like 3 root 3.
okay. So I'll give you the option. So A is what? A is 3 root 3. B, okay, 5 root 3. C is what, root 3. D is root 11. This over, wait, I'll solve this. So I guess the minimum closest to the point this asks. So the minima is root 3 only, right? Sorry. Yeah, so 3 root 3 is correct. Okay, I'll solve this one. So I told you this is the 3-dimensional thing, and this is the sphere we are having. For example, this is x, y, z point, and this is 4, 4, 4, 4. Now you need to calculate the distance, and this distance you need to minimize, right? So this is our optimization problem. So optimization problem is what? You need to calculate the distance. So you can calculate d square is what? X minus 4 ka whole square plus y minus 4 ka whole square plus z minus 4 ka whole square. So this is our equation: x minus 4 ka whole square, y minus 4 ka whole square, z minus 4 ka whole square. This is our optimization problem. And the constant equation is what? The constant equation is this one. This is sphere. So x square plus y square plus z square equals to 3, because all the points will lie on this equation only. So this is our constant. So this should satisfy. So all the points should be on the sphere itself, because we have to calculate the minimum distance from the sphere to that point. Okay. So this is clear, right? So optimization problem and constant. So if I'm having this equality form of constant equation, we can use the Lagrangian multiplier, right? So to calculate the Lagrangian multiplier, we should be knowing del of fx. What is the value of this? So you can differentiate this. So you'll get 2x minus 4,
Yes.
2y minus 4, 2g minus 4, right?
Yes.
Similarly, you can calculate the del of g, x, y, z, g. Should be equals to what? 2x, 2y, 2g, 2g, right? And we already know this should be equals to minus of lambda, or the lambda, because it's a Lagrangian, so you can use lambda also. Sorry, Lagrangian, I'm saying the equality form up. So in equality, what happens? This should be equals to minus lambda, and lambda will adjust the value itself.
Yeah.
Okay. So now you can equate it. 2 of x minus y should be equals to x of x minus 4 should equals to 2x lambda. So what the lambda you'll get here from here? So you'll get what? X will get as lambda 1 minus lambda. Sorry. Where the value you'll get? X should be equals to what?
I got no, but I took 4 minus x, so but I got x is equal to 8 by
4 by
2
1
minus
minus
lambda.
lambda.
Yeah, that's what I 8 by 2.
Similarly, this equations are same, so you'll get y also same. Lambda and z also you'll get same. Right? Okay. So now what you can do, you can put it. So if you'll put it in the constant equation, so you'll get what? You'll get, what is the constant equation? X square plus y. So x is what? 4 upon 1 minus lambda, right? 1 minus lambda. Ka whole square into 3 equals to 3, right? This is what we are getting. So
Is it 4 by 1 minus lambda or
what one?
is it 4 by 1 minus lambda or like
4 upon this equation you are
yeah,
saying.
yes. Sorry.
So 2x minus 4 equals to 2x lambda. So 2
Yeah,
got cancelled. So 2x minus
yes. It was by
2x lambda equals to 4. So you'll take x as common. So 2 got cancelled, right? So x 1 minus lambda equals to 4. So 4 upon 1 minus lambda. So 3 got cancelled. Now what is left with you? So 16 upon 16 equals to 1 minus lambda ka whole square. This is what you are getting, right?
we can do plus or
If you
minus.
solve 1 minus lambda equals to plus minus 4, lambda you will get how much?
So it will be either like 5 or minus.
5 minus
Yeah,
4 plus minus 4 minus 1 minus this lambda. So you'll get 3 or either minus 5, right? Okay.
yeah,
So now,
minus lambda.
okay, and then you need to put, so according to the lambda equals to 3 or minus 5, you'll get the values x, y, z. So you'll get the values as, what are the values
Should
you'll
be
get?
like 4 by minus lambda.
So one value you'll get 1, 1, 1, because 4 upon 1 minus lambda you're having, right? This is what you're writing. Okay. So 4 upon 1 minus 3. No.
Yeah, I think it is minus 3.
Sir, how did you get 1 minus lambda?
Minus 3 and 5 we will get.
Yeah,
Minus
yeah.
Okay, minus
The
3 or
signs.
minus 3 and 5.
and 5, yeah.
Yeah, that is
Okay.
correct.
So then you'll get, okay, so you'll get 1, 1, 1 as 1. Yeah, somebody is asking what? Lambda?
Sir, how did you get 1 minus lambda? I'm getting 1 plus lambda.
1 minus lambda. Where?
Yeah, sir, I mean all of this. So, sir, when you did the Lagrangian multiplier equation, so I am using del of fx equals to minus lambda del of gx. So that then I'm getting, the x value that I'm getting is 4 by 1 plus lambda. So you're getting
Okay.
4 by 1 minus lambda.
So the value, the lambda should not make any, I guess, problem, because even if you're writing minus lambda, okay, so here you'll get plus plus, but the lambda value you'll get minus minus 5 or something, so that the value, so that you'll get the different lambda here. Are you getting my point? So the lambda value will get adjusted. If I'm taking minus lambda here, so the lambda, like I'm getting what? I'm getting 3 or minus 5 here. So you will get something like minus 5 or 5. Right?
Yes.
So that in the, because then you have to take everywhere minus lambda now. So the value will get adjusted itself. When I'm taking lambda, it should adjust itself. Right?
Okay. So I mean, it should not make any difference.
It should not make any difference from my point of view, but I didn't, like, whatever I solved 4-5 questions, it didn't make it, like from the starting we are solving taking positive only, so it's not making any impact, right? Here also it will not make impact. If you'll solve the equation, you'll get some, if I'm getting 3 minus 5, you'll get 3, you'll get minus 3 and 5, right? So the same thing you'll get. So if I'm getting -3 and 5, you will get 3 and -5. So that when you will put the value, like I was having 1 minus lambda and I put this value, so I'm getting 1, 1, 1. So when you will put that, so you'll get 1 plus lambda. So you'll put what? -5 you'll put, so or what you are getting?
I'm also getting 111.
Yeah, so 1, 1, 1 you're getting, right? So if you'll
Yes, sir.
yeah, so from 1, 1, 1 you'll calculate, you'll get the minimum value. Whatever the value you are getting, 2, 3 values you are getting. Like for example, lambda we got 2 lambda we got. So 2x1 x. So you'll get two values of x1, y1, z1, right? Like x, y, z. So according to the two values, if you'll calculate the distance, one would be farthest and one would be the closest one, right?
The case of sphere, actually, like we can just take the line between the origin and that intersection.
Origin and so yeah, farthest we can calculate directly. There is no issue in that. But one thing you need to calculate, right? Even we can calculate the Lagrangian multiplier is a one method. So basic, if we'll use some basic concept, we can also solve. So what we need to generally minimize this thing only. So if we have to minimize this equation, you can just do that partial differentiate. Okay, with the different partial differentiation, if I'm doing what I need to minimize this equation and satisfy this problem. There can be other method also, but
in the case of sphere, like you can use basic algebra. You can like draw a line from the
this point
center, from the center to the point, and that will obviously be the minimum, right? And find the intersection with the sphere.
Okay, so from here to here would be the distance.
Not the distance, right? If we take y is equal to the slope times x, right? Because it is origin, you don't have the y-intercept coordinates. So you can take like what for.
So can you repeat that? Like if I'm having this, okay, so this is a different method. This is not like related to anything regarding ML. This is a basic math. I'm having this circle like sphere. I'm having some points here. Like for example, this is a sphere, and there should be some tangent. Okay, so there should be some tangent, and then what you told? Okay, so from the
origin, like if you take the point and the origin, right, the line going through the point and the origin, basically the line segment.
So this line will be perpendicular to each other because it's a tangent, right? You'll get a plane here. You'll get a plane here.
That will be the point of intersection with the sphere. So you can take.
Okay, so this is a plane, for example, W transpose some x is equal to B. Okay.
Yeah, exactly.
This is a plane, and if I'm just okay, so what I can do is this is a plane XYZ. This is a XYZ value. This is a 4, 4, 4. So we can just write the equation as a plane also that is passing through the XYZ and is perpendicular to 4, 4, 4. So there is some equation x upon y upon some method is there to write the equation plane.
Yeah.
Okay, so this will get some equation of plane. And that this should be a bit complex, but yeah, it can be solvable with some basic property. If somebody is doing regarding the plane, and he can solve. But Lagrange is a pretty simple one, right?
Yeah. I mean, for cross reference, if you want to cross check, you can use.
Okay, so this was the question. So is it clear? Like whoever was asking to solve this problem, is it clear? Do I need to write anything else?
Yeah, so it's clear. But I mean, could you just give us give the answer? What the answer is for this question?
The answer is 3 root 3.
3 for the shortest and 5 root 3 for the longest, is it?
Yeah, because you can add the root 3 into 2, like the diameter of the sphere. Okay. So this will be 3 root 3 plus 2 root 3. This is 5 root 3 would be the farthest. And the point would be you can take the reflection of 1, 1, 1 in that 0, 0, 0, right?
Yeah.
So if you are taking the reflection of 1, 1, 1 in 0, 0, 0, so you'll get what? What is the reflection of this 1, 1 here? This would be minus. So every time this minus.
Sir, I have one more question here.
Yeah.
So, sir, here we had an equality constraint, right? So that's why so I have a question on minus lambda and lambda on Lagrangian multiplier. So so here it didn't make a difference, but is there a case where it will make a difference? Because sir, this is an equality constraint, and here anti-parallel, both of the solutions will be.
So we generally use Lagrange whenever we are having equality constant.
Okay.
So every time we use the Lagrange wherever there is a equality constant, right?
For the inequality constraint, then sorry, I'm not able to recall. But what do we?
Yeah, inequality. So we use the same thing, right?
What?
Inequality also we use the same thing, right? For equality, the difference is we take both cases of lambda, right?
Okay,
we take lambda and
correct,
minus
correct.
lambda.
For the
only for
yeah. So what happens if you are having, so the lambda value will vary. So if you are having for the, what you can say, for the equality constant, sorry. Yeah, I was wrong. So for the equality constant, so if you are having this minus lambda, so this lambda should be positive. But, and for the inequality constant, for the lambda you're taking, the lambda can be anything, right?
Yeah, any scalar.
And the lambda value should adjust itself, because if I'm taking not lambda, okay, so what you can do, you can just solve every time with taking minus lambda itself. Okay, so this should give you the positive value. Okay, because this has been discussed in the lecture, because of that basic approach that the dot product should be negative.
And the case of equality, we'll again take the negative of that lambda, and that's one more case when we come to the case of equality.
So this is, so one thing that I told you, that was like for the inequality, for if you are having the equality constant, so I'll just write it here again. So till the time you can solve this 12th one, calculate the Hessian matrix of this equation at this point. So Hessian matrix you already know, right? So how to calculate the Hessian matrix. Okay, so yeah, so solve this question, then I'll tell you the.
Sir, one more thing. So whenever we are getting values in sign, so there were a few questions. I think it was in the graded assignment. So the value sign was like a number. So that should be taken as a radian only, right?
Okay, so a theta value you are saying?
Yeah, sometimes it's a very odd number. So we just take radian for that, right?
And it has not been clarified in the graded assignment.
Yeah.
Okay. Okay. So I don't know how did they prepare the question, but they should write that. So you can just write in the radian form itself. So according to the option, you can write, and if this is not in the option form, you can tell me the question. Maybe I'll just remove that question, or maybe because now we can't edit that, so we can remove that question because it's not given in. If there is no mention how to write, because somebody can write in the radian or somebody can write directly the value, right? There's a graded assignment, right?
I think it was last week 8 assignment.
Week 8. Oh, week 8 has already passed. Date has passed,
Yeah.
I guess.
No, sector is the same. I think.
Okay. So for week 8 also the date is left, right?
In both are the same day. Week 8 and
Which question?
Sir, it's for practice assignment of week 8. There is one question.
Week 8 question.
Sir, it's in the practice assignment. So it's not in
Okay,
the grade.
practice assignment. Okay, that I'll edit it. So there's no worry about that. I thought it's not. Okay, this last question. Okay. Okay, I'll just read this. I'll just solve this and I'll write. So you're getting the answer in which form correctly? Radian form.
Right.
Okay, so I'll just write it here. To write in the radian form. Okay, I'll do it.
Excuse me, sir.
Yeah.
Sir, the calculator which is provided to us above over there on the screen. So
Hmm.
I think it is not telling us radian value is coming negative or positive. So it is creating a lot of confusion over there.
Okay, so better to use that hand calculator.
Sorry, sir.
You can use the hand calculator. Okay, for the exam, you'll not get this type of like in the exam everything will be clear with them. Okay, and if you are not able to calculate with the help of those, problem will not be given in the exam. So only those questions will be given that you can solve with the help of those calculators. So don't worry about the exam. And this, okay, so you are saying if I'm calculating something, how to use this one. If I have to calculate some 37, okay, how generally you do this? Cos of 37 and this, okay, so cos of 90 is 0, right? Okay, so it's taking theta. Okay, how generally you change it? Okay, this is d in degree and now it's taking in radian. If I have to
Like,
calculate,
so if you will put cos -7 and sine -7. So for sine -7, we should be getting negative value, but it is not showing negative. Sine -7.
when I for the first time using this calculator, -7. Okay, how to write this -7 here? Okay, now it's -7 and 7 will get, okay, so this is in the form of radian. So what you saying, this will should get the okay. And how can you calculate degree to radian?
So first we have to select minus, then 7, and then sine.
Okay, no, that is fine. I'm just asking how to calculate. So 1 degree
365.
into pi upon 180,
Yeah, by 1 day.
right? This will get in the form of radian, correct? So 1 degree is what? 1 degree is 180 upon pi. How much you'll get? How much?
Degrees pi by 180. P to P what? 11 by 7.
Okay, so 0.175 here. Okay. Enter. So what was your problem? So if I'm taking -7 and cos of -7, it's giving positive. So it's giving positive only.
Yes, so this one is right. Then if I will go for -7 sine value, then
Okay, -7. So sine of -7 in the form of radian I'm applying.
This minus after 7 is making difference because this is calculated as minus sign R.
yes, you're
Okay.
putting
Sir,
minus on.
sir, will you please write it into brackets so it will take it as a -7 and then sign. Yeah, it is getting right, -7.
So
Yeah.
can you show the other question again? Like, what is the point at which we are doing? Like,
The point is 0, 1, pi. Okay. So what you are saying, this value should be positive. This is what you're saying, or what? What is the error in this? Like I can just tell the
No, sir,
thing
now
in.
I got it. I wasn't putting brackets, so I wasn't getting the right values at that time.
Okay, fine. So there is no problem from the calculator, right?
No, sir, no, sir. Thank you, sir. Sir, practice assignment question number 3 also, I'm having a bit problem in that.
Practice assignment, which 9th week.
Yeah, this week. So question practice assignment 8 only. Question number
Okay.
3.
The volume of the largest cone that can be inscribed in a circle of radius 3. So this is what was there in the 8th week. The 8th week was to solve the optimization problem without any constant. Okay.
So the radius, we are getting the radius under root 9 minus x square. How we are getting that? I'm not able to understand.
Okay. Practice assignment, third question. The 8th. Does the solution is uploaded for this week or not?
Yes, the solution is there.
Okay. So if I'm having this, what was the question? The volume of the largest cone that can be inscribed. Okay. In a circle, this should not be circle, I guess. Sorry, it should be a sphere. It's a mistake, I guess. It's an error.
Yes, sir.
Yeah. So now, if we are solving this, what is the volume of cone? Formula for volume of cone?
1/3 pi r square h.
1/3 Okay. So this is the cone, right? And what is this should be under a circle, a sphere, right? This is what has been asked.
Yes, sir.
So x square plus y square equals to 9. So y equal to 9 minus x square. Sorry. So the radius going the last one that's inside. This is where the center. Okay, so let's for example, r square is fine. Wanted to v is 1 by 3 pi r square h, right? And h is what? It should be equals to okay, wait. So what is the basic approach? Like if I'm having this sphere and I need to fit a cone inside
So
this.
you can take the radius, right? So
Okay, so this
calculate
height
the
and this radius, right?
yeah, and the radius. So it will be like an isosceles triangle at the bottom.
So it's
this hypotenuse will be the radius.
so this would be a
No, the hypotenuse. Yeah, that will be the radius of the sphere.
okay. So this
And
this would be what? This would be
and one
the
of them
height.
can be x, and the other could be the root of x square minus.
So the radius can be what? So 9 minus x square, right?
Yes, sir. Now I got it. Yes.
So r you can put it here. H also you can put.
Yeah. That is
So 1 by 3 pi r square you can put it from here. So you'll get in the form of x. H also will be form of x, and then you can differentiate it with respect to s. So you'll get some x, some x1 and x2, and then you can put it here. You'll get. I guess that should be the approach, right?
yeah, that is so.
Yes, sir.
Okay. So fine. So this one we have discussed. So this is the last question. So which of the following is the correct one? Even I don't have the answer for this question. Okay, so we'll try to solve this. So how to solve this? Everybody knows, right? So if I'm having in the form of x, y, z, x, y, z, right? So you need to double differentiate this function with respect to x. Whatever the function you are having, and then this with respect to partial differentiation with respect to xy, then xz, similarly xy, y square, like partial differentiation with respect to y square, like you have to differentiate it with respect to y and then again y, and then yz, So similarly, you can do xz and yz and z square. Okay. So what you will get? The values. What you will get?
9.
Okay. So you'll get the first value. What you'll get? So you'll just try to.
It will be
Okay.
8.
So first value should be 1, 1, 1 or 5. Okay. So the first value, you'll just take this. This will be of some constant sine of yz. You will get e to the power minus x and minus 1. And again, if we'll differentiate it, we'll make it positive, right? And now we have to put it value 1, 0, 1 pi. So 1 pi sine pi. What is the value of sine pi?
0.
0. So from here itself, we'll get A as option,
Yeah.
right?
Sir, can you please calculate the value for f of yz? Because I'm getting 0 for it.
F of yz.
Yeah, maybe I'm doing some mistakes.
Okay. So f of yz, f of yz. So this value you are saying, right? This
Yeah, right.
one. Okay,
Yeah.
this one. We are getting. Oh, okay. So yz, if you have to differentiate it, so e to the power minus x is some constant. Now differentiate it with respect to y. So sine of yz is what? Cos of yz multiply with this z, right? Now you'll differentiate it with respect to. Now you have to differentiate it with respect to. We have differentiated with respect to y. Now do it with z. Okay. So e to the power minus x. Z is cos ka. What is minus sine? Yz. Then okay, no, this is a mistake I'm doing. So this will come in the form of product form. So now you have to do the product.
Yeah, sir, I was not doing
The
correct.
second term will be
Okay.
0. The first term.
Yeah. So the product you need to do the product form. Then we'll get. Maybe that will be the error, I guess.
Yeah, sir, that was there.
Yeah. So I guess the first one itself is the correct one. Anybody else is having any doubt in this? Hessian, how to write the Hessian matrix? Does anybody have any issue in this? I'm just searching one question here and just wait a minute where I kept it. I'll just stop the screen sharing for 1 second because that is the quiz question itself. So is it my screen visible now? No.
No, sir.
Okay. There's that question. 1 second. Wait. So if I'm having this type of equation, I don't know whether I'll be able to solve or not, but okay, let's discuss this. If we are having this equation f y z, this is in the form of minus x square minus 2y square minus 2z square plus 2xy plus 2yz. Okay, so how will you write the matrix for this equation without having any options and all? I will try. So I'll also try to write, but how will you try to write this?
Like using the almost the same format as the equation, like -1 along the diagonals will be -1, -2, -2.
Along the diagonal, you can write minus. Okay, so x, y, z. This is x, y, z. This is. So what? Because okay. So for the x, it should be -1, right?
Yeah.
-1, and for the y, it should be -2.
Yeah.
Correct.
Yes.
For my z also, it should be -2.
Yeah.
Okay. So now for the y square we wrote xy is what? The coefficient is 2. So we can write 1 here, 1 here because it's a symmetric matrix, right?
Yeah.
Okay. Similarly for y and z, we can write it here 1 and 1 here and 1 here because it's symmetric. Because it's symmetric.
Yes.
And for the zx, we have 0, 0. So this would be the matrix, right? 1,
Yes.
-1, 1, 0, 1, -2, 1, 0, 1, -2. Yeah. And then you can directly solve whether it's a matrix, a positive definite or not. So can somebody tell me what is this? Whether it's a options are positive definite, positive semi-definite,
Sir,
negative
how it
definite,
is
and
-1, -1, -2?
see, if you'll expand this, like for example, this is a, and if you'll write this x transpose ax, okay, so this the -1 should come in the coefficient of when you'll do the x square, because you are multiplying x, y, z and then x, y, z, right? So when you will do this, you'll get the coefficient of x square will be -1, right? After multiplying this.
Yes, sir.
Correct. Similarly, for y square, you will get -2 because that's why I wrote -2 here. For z square, you will got -2 when you will multiply this. There's a problem only you'll get when, so the problem you should be happy asking, the issue should be why I have written 1, 1 here because 2xy is there, right? So x is there. Where is x? This is x and this is y. So for xy, what happens when you will multiply, you will get the 2 term of xy. You will get 2 term of xy. So here it was 2, so I just wrote 1 and 1 because it should be a symmetric matrix. That's why I wrote here 1 and 1. And here it was 2yz, so yz, where is that? So I wrote here 1 and then again here 1 because of symmetricity. And I was not having zx, so I just wrote 0, 0. Did you get the point? And if you try to multiply this, just try this x, y, z and this matrix, this A matrix, and then x, y, z. You should get this matrix, I guess, after multiplying.
Yes, got it.
Right? So you can change by this method also. If you have been given any problem, I don't know, this type of problem was there in the quiz. So I just discussed because you should not get any issue in solving this type of problem in the exam. So this is clear, right? And I guess this is also clear. So you can calculate the Hessian matrix also. I guess we are done with this solve with us problem. So Wednesday there is a revision session. Please, maybe you can join that session 2 to 4, I guess. We'll try to discuss most of the problems or some sort of problems, all the concepts from the weeks and then the important concepts. So we have that, I guess, 2 to 4 revision session. And again, there is, okay, stats. So you have for the MLF, we have, and so mock also, if you want, mock can be discussed in like half an hour, right? So mock can be discussed in the next week. Just attempt that mock, and then we can discuss in the next meeting itself. Is this fine? Anything else from your side? I'll just share this PDF also. Most of the questions are pretty simple, so I don't think so there'll be issue. Yeah. So any issue from your side? Anything, any feedback, anything you want? No. Yeah. So anyone is having any problem, any issue? So did math started? Oh, Ravindra Jadeja has scored 100. Nice. Anyone is having any issue? You can ask, otherwise we'll close. I'll go and watch math.
No, sir.
Are you able to hear me or not?
Yes, sir. Yes, yes.
Okay.
Yes, sir.
So
Yes,
should I
sir.
close this? Like, is it done? So we'll meet on the Wednesday again.
Yes, sir. Yes.
Okay. Thank you, everyone. So
Thank you, sir.
you can ask me if you're having any issue on the like phone number you already have mine. So you can just ask me before the quiz if you're having any issue. Okay. So I'll just close this. I'll just stop the sharing.
Thank you, sir.
Yeah. Thank you. Thank you, everyone.
Thank you, sir.
Excuse me.
Yeah.
So you told about contact numbers, so I'm not having yours.
So I'll just write in the chat box. You can just
Okay, sir.
take
Thank
it
you.
from
Thank you, sir.
there. Yeah. I just keep it on like the contact number I just shared in the chat box itself. You can just, anybody is
Yes,
having
sir.
an issue, you can just WhatsApp me. Yeah. Okay. So I'll close this session now. I'll just ask them to close this. Thank you, everyone, for joining the session.